Breaking the sound barrier. What's that loud noise? Have you ever heard a loud boom out of nowhere? It can be quite startling, especially when you don't expect it. Like an explosion in the distance. It can make you wonder what just happened. That could be a sonic boom. It's a fascinating phenomenon. Imagine a jet plane flying faster than the speed of sound. It's an incredible feat of engineering and physics. It's moving so fast it creates a powerful sound wave like a giant ripple in the air. This ripple is what we hear as a sonic boom. This ripple causes that booming sound we call a sonic boom. It's a sudden and loud noise that can be heard over a large distance. It's like the sound of thunder but made by an airplane. Just as thunder follows lightning, a sonic boom follows the jet. Sonic booms can be startling. They can catch you off guard and make you look up at the sky in surprise. They happen when objects travel faster than sound, which we call supersonic. This is a speed that exceeds 767 miles per hour at sea level. We measure the speed of sound in Mach. Mach 1 is the speed of sound, and anything above that is supersonic. Mach 1 is the speed of sound, so Mach 2 is twice the speed of sound. Imagine traveling at such incredible speeds. When that jet breaks the sound barrier, it creates a sonic boom that travels to our ears. It's a testament to human ingenuity and the power of modern technology.
Let's talk about sound. It's something we experience every day, but have you ever wondered how it actually works? Sound travels in waves, kind of like ripples in a pond. Imagine the surface of a still pond, and then picture what happens when you disturb it. When you drop a pebble in a pond, you see waves moving outward. These ripples spread out in all directions from the point where the pebble hit the water. Sound works in a similar way. When a sound is made, it creates waves that travel through the air. When you talk, your vocal cords vibrate, and these vibrations create waves in the air. These sound waves then move outward from your mouth. These waves travel to our ears, and our brains interpret them as sound. It's a fascinating process that happens almost instantaneously. The speed of sound isn't constant. It can vary based on several factors. It changes depending on the temperature and what the sound is traveling through. For example, sound travels faster in water than in air. In warmer air, sound travels faster. This is because the molecules in warm air are more active and can transmit the sound waves more quickly. That's why sound travels differently on a hot day compared to a cold day. On a cold day, the molecules are less active and sound waves move more slowly.
Now imagine that pebble in the pond again. Picture it falling gently, creating those familiar ripples that spread out in perfect circles. But what if you could throw it really fast? Faster than the ripples could move out of the way. What would happen then? The pebble would slice through the water, leaving the ripples struggling to keep up. The ripples would bunch up in front of the pebble, creating a big wave. This wave would be much larger and more powerful than the usual gentle ripples. That's kind of what happens with a sonic boom. When an aircraft travels at supersonic speeds, it creates a similar effect in the air. When an object flies faster than the speed of sound, it outruns its own sound waves. These sound waves can't move out of the way quickly enough. These waves get compressed together, forming a cone-shaped shockwave that trails behind the object. This shockwave is a powerful force, pushing through the air with incredible energy. This shockwave is what causes the sonic boom we hear on the ground. It's a sudden, loud noise that can startle people and even shake buildings. The sonic boom is a dramatic reminder of the incredible speeds that modern aircraft can achieve.
Section 4. The sonic boom's impact. More than just a loud noise. Sonic booms are loud. They can be disruptive and even cause damage. That's why supersonic flights are usually restricted over land. Imagine windows rattling or even cracking when a sonic boom passes by. Scientists and engineers are working hard to find ways to reduce the noise of sonic booms. They're designing new types of aircraft with different shapes that create quieter shock waves.
Section 5. Quieter skies. Designing the future of flight. Imagine a future where supersonic flights are common, but without the loud boom. That's what researchers are working towards. By changing the shape of airplanes and how they fly, they're trying to make sonic booms much quieter. One idea is to create a softer sonic boom. Instead of a loud boom, it would sound more like a distant thump. This would make supersonic flights much less disruptive to people and animals.
Section 6. The future of aviation. Faster, quieter and more efficient. The future of aviation is exciting. We can dream of flying across the country in a few hours thanks to supersonic technology. And with quieter sonic booms, it'll be a smoother ride for everyone. So, next time you hear a sonic boom, remember it's the sound of progress. It's the sound of innovation and our desire to explore new frontiers, pushing the limits of what's possible in the sky and beyond.